Good day to you all. Welcome back to our fourth lesson on calculus. In this lesson, we are going to talk about differentiating complex algebraic expressions. The first type that we are going to look at, the variable is in the denominator or when the variable is under the square root sign. If we look at number 1 there, our variable that we are working with is x, and we have got x to the power of 4. So we need first of all to fix this part. How do we fix this part? We will use the laws of exponents. So this becomes 7 over 2 x to the power of negative 4. Once I have written it like this, then I can proceed to apply the rules of differentiating. But before I apply the rules of differentiating, I want to point out to you that every time when we have a scenario like this, we are not interested in the number there. So we leave the number in the denominator because we are interested in differentiating with respect to x. So we need to carry the x to the top, and when we multiply the rules there, then we are going to write here, therefore, the first derivative of f of x is equal to, when I multiply 7 over 2 times minus 2, I'm going to get minus 14. But remember what we said, every time when we do this rule, the exponent is going to reduce by 1. So we are going to have x to the power of negative 5. Then I can write my answer with a positive exponent, depending on what the examiner is asking you to do. So this will be equal to negative 14 over x to the power of 5. And that will be my final answer. The second one that I have for you, number 2, we are given that f of x is equal to the 5th root of x squared. And in this case here we have a set. How do we rewrite this? We can rewrite this as x to the power of 2 over 5. And once we have written it like this, we can now apply the rules of differentiating to get the first derivative of the function that we were given. And in order to apply our rule, the coefficient here is 1, so we multiply here by 1 and we get 2 over 5 x to the power of what? Remember what we said, this must be reduced by 1. And if we reduce this by 1, we are going to get x to the power of negative 3 over 5. And like what I did in example 1 here, I can also write this as positive exponents, and my answer is going to be 2. The 5 was already in the denominator, so it stays in the denominator, and it's going to be joined by x to the power of 3 over 5. Let's move on to the next one that I have. Suppose we are given that, this is now number 3, f of x is equal to 1 over the cube root of x to the power of 8. In this regard, we have to first of all change the set. So if we change the set, this is going to be x to the power of 8 over 3. And when I do that, I have to adjust it again. Remember now, my variable is in the denominator, so I have to move it up using the laws of exponents, and this is going to become x to the power of minus 8 over 3. Then I can start my process now. I can write, therefore, the first derivative of f of x is equal to, what is the coefficient here? It's an invisible 1, and if I multiply there, I'm going to get negative 8 over 3 x to the power of, and remember what we said, this must reduce by 1. So I'm going to subtract 1 here. And if I subtract 1 here, I'm going to get negative 11 over 3 as my new power. And again, I can rewrite this, depending on what the examiner wants, with a positive exponent. The 8 will remain in the numerator, the negative 8. 3 was already in the denominator, so it stays in the denominator, but it's going to be joined by x to the power of 11 over 3. So this is the first type that we have talked about in our lesson today. Remember, in our lesson today, we are differentiating complex algebraic expressions. Type 2. We are given brackets. Given brackets. Let's say we have this question here. Y is equal to 2x plus 5. It's one of the brackets, and then the other bracket is x minus 2. In order for us to simplify this, we can use the method of distribution that we learned in the lower grades. And if we do this, what are we going to do? You can do it step by step, or you can do it one shot. But in this video, I'm going to do it step by step. So we are going to get here 2x squared minus 4x plus 5x. If I do the inner, and then the outer is going to give me negative 10. And if I simplify here, because I see here I've got like terms, so this is going to give me 2x squared plus x minus 10, of which now I have simplified this. I can now apply the rules of differentiating. So I'm now going to write, therefore, I can pick any notation. I can say dy by dx is equal to 4x plus 1 minus 0. Remember the derivative of a constant. The derivative of a constant, this is a constant. The derivative of a constant is equal to 0. Always remember that. And by now, you should also have realized that if we are finding the derivative of a term, of an algebraic term, whereby the exponent of x is 1, we just take the coefficient. Maybe I can do this one in a cloud. Just think this one in a cloud. And I can say, let's say I'm being asked to differentiate 7x. If I differentiate 7x, my answer is going to be 7. If I differentiate minus half x, the answer is going to be negative 1 over 2. We need to learn some of these rules so that we can be faster in examinations. Remember, our examinations are timed. Right. The next type that we want to look at, type 3, is when we are given fractions. Number 1. D of x is given as x over x to the power of 5 minus 3x over x to the power of 3. I have to simplify this, and when I simplify this, I have to separate. This is the method that I'm going to use. There are other ways of doing this, but all the methods will work. But I'm going to use this method in this lesson. And I want you to check something out here. I am not going to drop the dx until this is fully simplified. And how do I simplify this? I now use the laws of exponents. And when I use the laws of exponents, this is going to be x to the power of 2 minus 3 x to the power of negative 2. Where are we getting the negative 2? Remember, there is an invisible 1 here. And when we subtract here, using the laws of exponents, this is what we're going to get. Now that my expression is fully simplified, I can now apply the process of differentiating. But when I'm doing the process of differentiating, I can now drop the dx. So my answer is going to be, if I differentiate here, this is going to be 2x. And when I multiply here, there's a minus and a minus. This is going to be plus 6x to the power of negative 3. I want to keep on reminding you that the power reduces by 1. We do not add 1. In differentiating, the powers reduce by 1. And then my final answer, depending on what the examiner wants me to do, I can write this part here with a positive exponent. Right. Let's move on to the next one. We are still under type 3 of the fractions. Number 2, y is equal to 4x squared minus 9 over 3 minus 2x. Let's analyze what we have here. If we look at the numerator here, we have difference of 2 squares from grade 10. And if we look at this part here, we can also do what we used to do in the other grades called switching around. So in the top part here, we have difference of 2 squares. And then in the denominator here, we can switch around. Right. So let's continue the process here. In order for us to use dots, we are going to do factorization. So factorization is also very important in this topic when we are simplifying. So when we factorize here, we are going to get 2x minus 3. And then here we are going to get 2x plus 3. Everything over. If I switch around here, what am I going to get? I'm going to get negative, open brackets, 2x minus 3. What do we notice here? I notice that I can cancel out this bracket here is the same as this bracket here. And when I cancel out, I'm going to be left out with 2x plus 3 over a negative 1. And if I divide it through there, I'm going to get negative 2x minus 3. And when I've done this, I can now apply the rules of differentiation. And I can pick this notation here. I can say, therefore, y prime is equal to negative 2x. Remember what we said, the power here is 1. So we can just take the coefficient. Now, let's move on to number 3 under fractions. And this one is going to be the last one in today's lesson. Let's say they give us this question here. Number 3. Under number 3, we have f of x being equal to 2x squared plus 3x plus 1, and our denominator is x plus 1. If we look at what we have at the top here, we have a quadratic trinomial, or we have a quadratic expression. And in order for us to factorize the quadratic expression, we have many methods. You can pick the method that you are comfortable in using. So we are going to say this is equal to, we have to open 2 brackets here. This is going to be 2x plus 1. And here this is going to be 2x, not 2x, but x plus 1 over x plus 1. This method that we are going to use here depends on the method that you are comfortable in doing. There are so many methods that you can use, right? And again, we can also note that this can be cancelled, and if we cancel that, we are going to remain with 2x plus 1. After that, I can continue with my process. Therefore, the first derivative will be equal to 2. So, to summarize today's lesson, in today's lesson, we discussed 3 types that we can see as we endeavor to differentiate complex algebraic expression. The first type, so we had type 1. What are we saying in type 1 here? We are talking of the variable here. And we are talking of the position of the variable. Where is the variable? It is in the denominator, or it is under the root sign. Then in type 2, what did we talk about here? We talked about brackets, and we used the methods from the lower grades. Some people, they call it FOIL, first, outer, inner, and last. Some people, they prefer to use the word distribute, using the distributive property. And then in type 3, we discussed fractions. And maybe this could be the one that is the most challenging of them all. But under fractions, again, we saw that factorization was also very important. Factorization. So you need to revise your factorization and make sure that you are proficient in as far as factorization is concerned. Basically, this is what I can say in our lesson for today. We're talking about differentiating complex algebraic expressions. Thank you very much.